So if you have been following my series, I've been having this series on why is Go fast, concurrency, Go routine in Go, and we have treated mutex and wait group and even error group. So please, if you haven't gone through that playlist, you can please go through the playlist so that you can follow along, you can code along. So for today's video, I don't know if you are familiar with it, but Go in newer Go version, Go has found a way to refactor wait group in such a way that you don't necessarily need wait.add anymore. You don't necessarily need wait.done anymore. So we all you all you need is the simple, just call your weight group in a Go routine, right? So right now what we are going to do today, we are going to refactor this code, right? I'm going to refactor this weight group code, take out weight.add, take out weight.done, and see how it goes, right? And we're just going to do that and see how it goes. So now let's get to it. As usual, we're going to write our function here, func new weight group. Let's just, if I can spell it well, new weight group in Go, right? So the question you may be asking is why did Go refactor it? Go is known for its its sim its simple language. Like Go is big in quotes on clean coding, right? So Go wants you to write your code cleaner and write as fewer lines of code as you can possibly, right? So now let's start with our counter. We have our counter here. We are going to the same thing. We are going to have our var wg sync dot wait group, right? We also have the same thing, var mu, our variable name mu. We have to sync dot mutex. Please, if you don't know what wait group does initially, if you don't know what mutex does, please feel free to go through my this playlist, go through my channel, go through this playlist. I'll drop the link in the description, so you can start from scratch, learn about wait group, learn about mutex, and then you can follow along, right? So don't be don't don't panic if you don't know what this is, but I'll try and explain it here too. But it's better you go through my previous video, right? So we are going to again range for I equals starting from 0, from I starting from 0. We are going to do, yeah, like we usually do. Let's just try and range 1000, right? 1000. Then we are doing I plus plus. So as you can see, this is basically the same thing we have here, right? Basically the same thing we have here. So what we are going to is we are still going to range through 1000 and refactor this in such a way that we don't need the wait.add anymore. We don't need the wait.done anymore, right? So what is the new way that Go wants you to write your wait group in a very simple way, minimal code? So we start with wg.go. So it's a function. We're going to run this function here, func. We're going to run a function in here, and in that function we do the same thing. So we just do mu.lock. If you don't know what this is in mutex, please refer to my previous video. So what we are just doing, we're locking these resources, the resources that we want to manipulate, so that to avoid race condition. Like I said, I don't want to sound like I'm dragging it, but please you can check out race condition in previous videos. So we are going to still do mu.unlock when we are done. So and funny enough, that is all. You can see this line of this piece of code is smaller than this piece of code. So now what we are going to do in the real essence is that we are going to run both of them and see which takes longer, right? But let's just finish up with this. We have wg.wait. We are still going to wait for it to finish, and then we'll print. Let's just print it here. Let's just copy, yeah, print it here, and just to differentiate it with, right? and then let's clear here. Let's clear this. So let's call our func main and call it we're going to call our new we are going to call this function here new wait group in Go, and let's see if it works exactly. So before we call this function, let's comment this out. Let's also call with mutex. That's the one that we did the one we refactored, and see what we are going to have there. So if you do go run main.go, you can see with mutex gives you 1000. So let's see if we are going to have the same. Yeah, are we going to have the same? Yeah, so let's call it with the new wait groups. Yeah, it gives you 1000 too. So now let's play around with this. Let's see the time taken. So because we want to see which is faster, right? Let's just do start time. We're going to do start time dot now. What's happening? Start equals to time. Yeah, time dot now. That's what I'm looking for. And then we are going to do duration, right? And our duration is going to be basically duration is going to be time dot since, and then we put our start time here since the start time, and then again we're going to print it so we can know what we are doing. fmt dot print printf. Let's do time taken, and we print it on time taken, that's v, call it as v, then duration. So basically let's just do the same thing for the one with mutex. Paste this here, put our start time, start equals to time dot now. So what we are doing, we started immediately, and then we take note of the time duration. So now let's call the one with mutex first, and then we get to see that this takes about is that 497 point, that's about 497 is that micro or nanoseconds. Well, that's very fast. So now let's call it with new wait group, and we can compare. Well, you can see this, it seems this takes longer than this. So maybe you want to the thing about clean code in Go is that you might need to have one or two trade-offs, right? So let's call it again side by side, right? Let's call it again side by side. Well, go run main.go. This is with mutex. Okay, with mutex we are having this. What are we having? With mutex we are having this. While we are having, so yeah, let's just do new line, right? Let's put a new line so that we can take note of this new line. Again, let's clear this, and let's go run main.go again, so we can, yeah, so with mutex we're having this, while with the new wait group in Go we're having this. Well, you can see it fluctuates. It actually fluctuates. You can't really tell. The thing with goroutines and concurrency is that you can't really tell when which is running, but all you know that is very, very fast compared to running it without goroutines. You know, if you are familiar with my channel, I try to come up with simple concepts in Go that a beginner can follow along, code along, and then explain it as much as I can. So if you're a beginner, please subscribe, like, share.